Our next lesson in conic sections is the ellipse. Here, we will learn about its definition and a general form. Also, we will tackle the equation of an ellipse in standard form. We will also reduce the equation of ellipse from general form to the standard form. Definition and a general form. The ellipse is the conic section with eccentricity less than 1. That is, the ratio of the distance from a focus to a point and the directrix to a point is less than 1. In this figure, we have an ellipse, and your point F is the focus of your ellipse, with point P with coordinates x and y. Its distance going to your directrix and to the focus is given by the equation of its ratio. The directrices. These are the fixed lines of distance d from the center. Foci is the fixed point of distance c from the center. Major axis, the distance from vertex to vertex. The distance from center to vertex is a. Minor axis. The axis perpendicular to the major axis. The distance from the center to the endpoint of the minor axis is b. Latus rectum. The segment passing through the focus and perpendicular to the major axis. Its total length is 2b squared over a. The eccentricity of the ellipse is obtained by the following sets of equation. C over a is equal to e. A over d is equal to e. The following equations are true for an ellipse. A squared is equal to b squared plus c squared. C is equals to ae. D is equals to a over e. Thus, eccentricity is equal to square root of a squared minus b squared all over a. Theorem. An equation of the second degree represents a conic section, and conversely, ax squared plus bxy plus cy squared plus dx plus ey plus f is equal to 0. The ellipse is defined as the conic, whose eccentricity is less than 1. It is generally represented by the equation ax squared plus cy squared plus dx plus ey plus f is equal to 0. We note that a is not equal to c, but both are positive. Your b is equal to 0. Thus, the term containing xy is not present in the equation of our ellipse. Standard equation of an ellipse. Ellipse with center at the origin and ellipse with center at coordinates hk. The standard equation for ellipse with center at the origin, with major axis parallel to the x-axis, x squared over a squared plus y squared over b squared is equal to 1. Ellipse with major axis parallel to your y-axis, x squared over b squared plus y squared over a squared is equal to 1. We take note the position of our major axis. If it is parallel to x-axis, the square of its semi-major axis is in the denominator of the term containing x squared. If your major axis is parallel to the y-axis, the square of its semi-major axis is in the denominator of the term containing y squared. Ellipse with center at coordinates hk. The standard equation for ellipse with center at coordinates hk, with major axis parallel to the x-axis, x minus h squared all over a squared plus y minus k squared over b squared is equal to 1. With major axis parallel to the y-axis, x minus h squared over b squared plus y minus k squared over a squared is equal to 1. The same is true with the ellipse at center hk. The square of the semi-major axis is in the denominator of the term containing your x minus h for the ellipse with major axis parallel to your x-axis. For the ellipse with major axis parallel to your y-axis, the square of the semi-major axis is in the denominator of the term containing y minus k squared.